Hello. So this section is 2.2, which talks about linear inequalities in one variable. So the goal here in this section is we want to learn how to solve inequalities, and then we want to do applications involving linear inequalities. So let's make sure we're all on the same field here, the same page. We want to make sure we understand notation. This symbol means less than. Whenever you have that symbol and put a line under it, that means it's less than or equal to. This means greater than. This means greater than or equal to. Now let's start with a definition. If the equality symbol in a linear equation is replaced with less than or equal to, greater than or equal to, the result is a linear inequality. It is a linear inequality. So let's go over what it looks like visually. So if you are given an inequality symbol with specific, with a variable and a number, and it's written in these ways, then you need to be able to understand what this means in interval notation, what this means on an interval of a number, graphing an interval of real numbers on a real number line. So you need to know the graphical representation of it, the interval notation, and what the linear inequality looks like. Okay, this is understanding how to translate phrases. So here you have x is less than or equal to 4. In interval notation, this means we have parentheses, negative infinity, comma, 4, bracket. The bracket means we include the number beside it. The parentheses means we cannot include that. Remember that infinity and negative infinity are symbols used to indicate negative infinity means decreasing without bound. Infinity means increasing without bound. So they're not numbers. They're symbols used to indicate moving in a direction really large or really negative. Okay, so x less than or equal to 4 has this interval notation representation. Graphically, it means you take the number line, you put a bracket at 4 because we want to include 4, and then you shade everything to the left of it. Okay, here we have negative 2 is less than x, and x is less than or equal to 4. Or in other words, we can say x is between negative 2 and 4. It cannot equal negative 2, but it can equal 4. So because we have strictly less than, that means we have a parentheses. So we have a parentheses, negative 2, comma, 4, bracket, because we have the equal to as a possibility. So we have parentheses on our number line. We have parentheses at 2, shading everything between 2 and 4, and a bracket at 4. Now, x is greater than or equal to negative 3. We know automatically we're going to have a bracket at negative 3. And the fact that it's greater than that means we have everything to the right. So negative 3, comma, infinity. Remember, infinity is not a number, so we cannot have a bracket, but we can have a parentheses. Graphically, on a number line, that means we have bracket at negative 3, and then we have everything to the right, bolded and shaded. Okay, here we have 5 is less than or equal to x, and x is less than or equal to 10, or we can read this as x is between 5 and 10. So because these have equal to under them, that means we have a bracket at 5, comma, 10, closed bracket. On a real number line, we have our number line, we have bracket 5, shading everything up to 10, closed bracket. Okay, make sure you familiarize yourself with that. Now, there are some cancellation properties for inequalities, and this is important. If a is less than b, if you add c to both sides, that doesn't change your sign. If a is less than b and d is greater than 0, when you multiply both sides, it does not change your inequality symbol. However, if you have a is less than b and d is less than 0, so d is negative, if you multiply both sides of this by d and d is negative, that means your inequality symbol is reversed. important. So notice that if D is negative and you have A is less than B, then notice that you have the symbol is reversed. Okay? So if A and B are algebraic expression and D is a non-zero constant, then the cancellation properties 1 through 3 are true if you replace less than with greater than, less than or equal to, or greater than or equal to. Okay, so let's look at an example. Let's solve the linear inequality and let's describe the solution set using interval notation and by graphing. Part A, we have x minus 7 is greater than or equal to 5 plus 3x. So we want to solve for x. So we need to put the x's on one side. So we're going to subtract 3x from both sides to get x minus 3x. And we're going to add 7 to both sides. So we have x minus 3x is greater than or equal to 5 plus 7. Okay, so notice that happens. And so x minus 3x is negative 2x is greater than or equal to 12. Now, we want to get x by itself. So now we want to divide both sides by negative 2. But notice that that's the same thing as saying we're in cancellation property 3, so the sign is going to have to be reversed. Right now it's greater than or equal to. Whenever we divide, this is for space reasons only, whenever we divide by negative 2, that reverses the symbol. So we get x is less than or equal to negative 6. That's the inequality. Now we know if x is less than or equal to negative 6 on a number line, that means we have negative 6, bracket goes there. Because we have less than, that means we know we want to go to the left. So that means our bracket is going to be facing the left. And then we shade everything to the left of it. We have our arrow. And then in interval notation, that means we have parentheses, negative infinity, comma, negative 6, bracket. Okay? That is our answer. Okay? Excellent. One more example. Here we have a double inequality, okay? Or a compound inequality. So here we have 5 is less than 2m minus 3, less than or equal to 13. So in other words, we want to get m by itself. Same thing, we're just doing it to this side as well. We're going to add 3 to each part of the inequality because our goal is to get m by itself. So we're going to add 3 to each part. Notice that that cancels the 3 from the middle. So we get 5 plus 3 is less than 2m, and that's less than 13 plus 3. So we get 8 is less than 2m is less than 16. Now, we divide each part by 2. 8 over 2 is 4, so we get 4 is less than m, and that is up less than or equal to, be careful, is less than or equal to 8. So now we have m is between 4 and 8. It cannot be 4, but it can be 8. So graphically, on a number line, we know we have 4, we have 8. M is greater than 4, cannot be equal to it. So we know a parentheses opens to the right. At 8, we know m is less than or equal to 8. So that means it's 8 or less. It can be 8. So we put a bracket facing the left, and then we shade everything in between. That is the graphical representation on a number line. And then the interval notation is bracket 4, comma 8, parentheses 4 comma 8 bracket. So this is your final answer. Okay, very good. Now, you can talk about inequalities with absolute values. Okay, so that's the fact here. Facts 1 and 2. And these you need to know. So remind yourself of these. Make sure you put them on a note card if you need to, so you can remind yourself of what they are. Okay, so the absolute value of x less than a is less than a if and only if x is between negative a and a. The absolute value of x is greater than a if and only if x is less than negative a or x is greater than a. So let's go through and do example 2. We want to solve the following. We want to describe the solution set using interval notation and by graphing. Part A. We have the absolute value of x minus 2 is greater than or equal to 5. If we look back up at our facts, this is not fact 1. It falls in a fact 2 because we can replace greater than with greater than or equal to. So this is how we're going to interpret that statement. Okay, so this is equivalent to saying, using fact 2, this is equivalent to saying x minus 2 is greater than or equal to 5, or x minus 2 is less than or equal to negative 5. That's using this. Okay, so now we solve for x. Add 2 to both sides. We get x is greater than or equal to 7. Here we add 2 to both sides. X is less than or equal to negative 5 plus 2 is negative 3. So in interval notation here, when x is greater than or equal to 7, that means we have bracket facing the right, 7 comma infinity, parentheses. X less than or equal to negative 3, that means we have parentheses, negative infinity, comma, negative 3, because we have less than or equal to, we have a bracket facing open, a bracket facing the left. Okay, now we have both of these are part of our solution. The way we write this, we set these intervals up like we're reading them on a number line. So we would write the answer as negative infinity to negative 3, parentheses, negative infinity to negative 3, bracket, union, bracket, 7 to infinity, parentheses. That is our answer in interval notation. By graphing, we draw a number line. We have a bracket facing the left at negative 3. We shade everything to the left. And then we have a bracket at 7 facing the right. And we shade everything to the right. That's the graphical representation. Okay. Part B, we have 5.5 plus the absolute value of x minus 7.2 is less than or equal to 3.5. Now, here, this is not set up like either one of our facts yet. So let's subtract 5.5 from both sides so we can get it in that form. This means that cancels there, so we will be left with the absolute value of x minus 7.2 is less than or equal to negative 2.5. So then we pause for a second because this means we have the absolute value of x minus 7.2 is either less than or equal to negative 2.5. But then we think about it and we use our common sense. Whenever we talk about absolute value of anything, that means the only way it can be equal to, only thing it can be equal to is a positive. So this is not true. We cannot have the absolute value of x minus 7.2 is equal to negative 2.5. So the solution set here is the empty set. It's the empty set because it is impossible for the absolute value of any expression to be negative. Okay? And there you go. So now we've talked about linear inequalities. We've talked about absolute value, linear inequalities. Now let's talk about some applications of linear inequalities. Okay? So let's work on our translation. In this table, I've given us a phrase in the first column, and I've given us questions to answer. And the last column, I want us to write the actual inequality associated with this phrase. So for the phrase x is no greater than y, can x be less than y? Sure, yes, it can be, because it says x is no greater than y. So yes, that's a possibility. Can x equal y? Yes, absolutely. Can x be greater than y? No, because it says x is no greater. It says x is no greater than y. So this is a no. So the inequality is that x is less than or equal to y. Now, pause this video and see if you can fill these in without us going through them together first. So go ahead and pause and do that. Now you come back. X is at least as large as y. Can x be less than y? No. Can x equal y? Yes. Can x be greater than y? Yes. This translates as x is greater than or equal to y. Okay, the last phrase, y exceeds x. Can x be less than y? Yes. Can x equal y? No, because it says y exceeds x. Can x be greater than y? No, because it says y exceeds x. So this means x is strictly less than y. Okay, so now let's apply what we've learned. Okay, now in a series of 30 racquetball games played to date, Larry has won 10, giving him a winning average so far of 33.3%. to the nearest tenth of a percent. If he continues to play, what interval describes the number of games he must now win in a row to have an overall winning average greater than 50%? That's the question. Okay? So, here, how do we set this up? Our question says if he continues to play, what interval describes the number of games he must now win in a row to have an overall winning average greater than 50%? So let's let W be our wins, okay? So far, Larry has won. So in a series of 30 racquetball games played to date, Larry has won 10, giving him a winning average of 33.3%. So this is just extra information, the 33.3%. So if we know, we want to figure out if he has 10, let's use blue, that's what we've been using. He's won 10, so 10 plus W. W is the wins, right? Because we're trying to figure out how many, if he continues to play, what interval describes the number of games he must now win. So now we're trying to figure out how many games he has to win to have an overall winning average greater than the 50%. So whatever 10 plus W over 30 plus W is, we want that to be greater than 50%, which mathematically is 0.50. So now we need to solve this inequality for W. So we're going to multiply both sides by 30 plus W. So that means we're going to have 10 plus W is greater than 0.50 times 30 plus W. What did we do again? We multiplied both sides of this equation, or this inequality, by 30 plus W. That's how we got from here to here. Now, we want to solve for W. Well, that means 10 plus W is greater than 0.50 times 30 plus 0.50 times W. This means 10 plus W is greater than 15 plus 0.50 W. And now we want to simplify. We want to get W on one side. So we're going to subtract 15. And then we're going to subtract W. So that's the negative 15 minus 15 is 0. 10 minus 15 is negative 5. Notice that these W's cancel out here. So that means negative 5 is greater than. Then we have, this is an understood negative 1. So negative 1 plus 0.50 is negative 0.50. So negative 0.5 W. Okay. Now, what does that mean? Well, we have negative 5 is greater than negative 0.5 W. We want to get W by itself, so we want to divide by negative 0.5, but remember, if we're dividing by negative, that sign flips. So this becomes negative 5 over negative 0.5 is less than negative 0.5 W over negative 0.5. The negative 0.5s cancel out. Negative 5 divided by 0.5, that's 10. So we get 10 is less than W. That is, we can rewrite it as W is greater than 10. Okay, well, if W is greater than 10, our interval is parentheses 10 to infinity, right? Because it's strictly greater than. So parentheses 10 to infinity, or bracket 11 to infinity. So why even consider writing this? It says if he continues to play, what interval describes the number of games he must now win in a row to have an overall winning average greater than 50%. To have a winning average greater than 50%, we know that Larry has to win 11 or more games. And this is how we can represent our answer. All right, that's section 2.2. Do your homework.